Hello class, and welcome to the COMP-111 recording for week 2. This is our week 2 review of the lesson material. All right, so today we're going to talk about data types, variables, public statements, and constructors. So again, we're going to go back through some of the concepts that we did in week 1, and we're going to be constantly reviewing these because I know it may be a little foreign to you. So just hang in there. We're going to go over them, and eventually you'll be like, wow, I can't believe I struggled so much with those concepts. So just hang in there, and we will get through all these topics. Okay, so the objectives today, we're going to go back over classes, objects, and methods. We're going to talk about constructing or actually building an object. We're going to talk about the accessor and mutator methods that are a part of an object, the inputs and outputs of these methods. We're going to introduce test-driven development or JUnit test cases, and we're going to talk a little bit about API documentation. Okay, so a constructor, if you remember from week 1, a constructor constructs or builds an object from a class. So remember, we have our class, which is our blueprint, right? And from a blueprint, an object is built. So think in terms of construction. We have our blueprint that tells us how a house is built, but you can't actually live in that blueprint. And the same thing is true for a user-defined class, a user-defined data type class. It's strictly a blueprint to tell you how to build an object, so you can't actually store data and things inside that user-defined data type class. But when we construct a house and that house is built, then you can actually live in the house. And likewise, when an object is constructed from a class, then you can actually store data and use that object. Okay, so the primary purpose of a constructor is to initialize the instance variables or the data for that particular object. Okay. All right. Now a class, we have our user-defined data type classes. So there's actually 3 different types of classes that we're working with in this particular course. So we have our user-defined data type class, which is one where we're building a whole brand new data type, telling it what kind of data this data type is going to have, what kind of methods, what kind of actions, and all of that. And then there's the test-driven development class, which we're going to talk about a little bit later today. And then finally, we have an actual program. Okay, so we're talking here about the user-defined data type classes. So when we are actually defining a constructor inside one of these user-defined data type classes, this is what it's going to look like. Its access is going to be public, meaning we're going to let anybody use our constructor to build an object. We're going to give our constructor a name. Now, the Java convention is that the constructor name is the same as the class name. So whatever you call your class is what you're also going to call your constructor. And then following the constructor names, we're going to have an open and closing parentheses here with our explicit parameters. So these are any arguments that could be passed into this particular constructor that will then be used to build the object. Okay, so when a constructor is called, in which case it's called from a program, from a driver or a demo program. So this is, you have the definition of your constructor is in your user-defined data type class, and then you call it from an actual program, all right? When it's called, the format is going to look like, you're going to define your object. So you have to create an object that you're going to be storing, or an object variable that you're going to be storing this reference to the object in. So you would give it your class name, okay, the name of your object, which is whatever you want to be calling your object, equals new, a brand new object instance, the name of your constructor, which is the same as the name of your class, and then you're going to pass in here whatever arguments it is that you're going to be giving to this particular constructor. All right, so here's how that would look. This would be one class, your user-defined data type class, and this is a separate class, which is your program. So I've divided them up into 2 boxes here to kind of help you differentiate one program or one class versus another class, all right? So if we were creating a class that would represent a dog entity, okay? Our constructor would be public dog, and then here we have empty parentheses, so this means this is an empty or default constructor, meaning there's no explicit parameters for this particular constructor. All right, now if I'm going to call it, remember the format is class name, object name equals new, constructor name, and then you put your parameters in here. So our class name is dog. So we've got dog. Remember the name of your constructor and the name of your class is always the same. So dog, where I'm choosing to call it temp dog. You can make this anything you want to, right? It can be dog one, new dog, whatever you want to call it. I'm going with temp dog equals new, brand new object instance, and then the name of my constructor, which is also the name of my class, dog, and then my parentheses are empty over here, so they're empty here as well. So over here, I've defined my constructor. I've defined how you can go about creating a new object, but in a program, I actually create that object and then I can manipulate that object. All right, so this constructor, so the previous constructor was an empty or default constructor. So kind of think, let me go back to that just for a minute. When you're thinking about the empty or default constructor, think vanilla, right? Plain Jane vanilla, vanilla ice cream is just kind of a blank canvas. And then on top of that vanilla ice cream, you can add whatever you want to, right? You start out with the basics, and then you can go back to it later and you can add your chocolate sprinkles or your caramel syrup or your whipped cream or whatever you want to. And so you're just creating something basic here, and that's what a default or empty constructor is. Now, we don't have to have a default or empty constructor. I mean, most classes do, but you can also have what's called an explicit constructor where you actually provide the information ahead of time. So maybe you don't want vanilla ice cream, you want butter pecan ice cream instead, right? So you provide the details ahead of time. And so that's what we have here. This again is in our class, our user-defined data type class, and over here is our program that's going to be creating objects, okay? So here we have public dog, so still it's a public interface. Our choices are public or private, and constructors are typically public, meaning anybody can access them and use them. The name of our constructor is still dog. It still matches the same name as the class itself, but inside of here we have two data types. I'm sorry, two explicit parameters. The first one is data type string and is going to be represented by the variable dname, and the second one is data type integer and it's going to be represented by the variable name dage. Now I've got the dname and the dage crossed out here. Those two variables, so essentially what we're doing is we're defining two variables. So we've defined this variable dname with data type string, and we defined a second variable of integer with the name of dage. So we've defined these variables over here, and our user-defined data type class knows about them, but this program over here does not know. They just know, the program knows that when I call this constructor, when I call the explicit constructor, I need to pass it two arguments, and those two arguments are going to be the first one data type string, that's going to be the name of my dog, and the second one data type integer, which is going to be the age of my dog. But this program here does not know about the variables dname and dage. It strictly knows I need to pass it string data and integer data, and that's why I've crossed those out there, so that you're kind of getting an idea of focusing in on the data types, not on the actual variable names that are used in your user-defined data type. Okay, so over here in the program that you're writing that's going to create objects and manipulate objects, okay, it's what's actually going to be out there in the world that's going to be used. Again, when you call it, it's the name of your class name, so we still have to create our temporary object. So the name of your class name, which is dog, give your object some sort of a name, temp dog, equals new object instance, then the name of your constructor, which is always the same as the name of your class, dog, and then I need to give it two explicit parameters, two arguments here. First one data type string, second one data type integer, which is whole data. So we have Bruno is my string data. Notice it's enclosed inside the double quotes, and then 3 is my integer data. And so what happens is when this program calls my constructor, So I've got my user-defined data type class over here. When this calls the constructor in this class over here, it's going to take Bruno, and Bruno is going to be plugged into this dName variable. And then it's going to take 3, and 3 is going to be plugged into the dAge variable. And then the constructor can then access that data through those variables and assign instance variables equal to those values. Okay? Now I can do that, or what I can do is I could actually create some variables here. So I could do string name equals Bruno, integer age equals 3, and then I can call my constructor dog, temp dog equals new, and the name of my constructor, which is dog, and then instead of putting the actual string literal value of Bruno, so this is considered a literal value because it's enclosed in quotes, so it's literally the characters BRUNO, all right? And this is considered a numeric literal. It is literally the value 3. So instead of providing the literal values here, I can provide these two variables that I created, name and age. Still, name contains the value Bruno. So when this constructor is called, whatever is contained in my variable name gets put into this variable dName. Whatever is contained inside my variable age gets put into this variable dAge, and then this constructor would continue to process with that particular data. Okay, so let's take a look at a couple of these and just think about what could happen. So I have the constructor, it's public interface, so it's not private, it's public, anybody can access it, and the name of the constructor is house, and there's empty parentheses here, meaning there's no explicit parameters. So if I were to look at this, what would be the class name for this constructor? So remember, the class name and the constructor name is the same, so it would be house. The constructor name is also house. There are no explicit parameters because the parentheses are empty. And a good object name, remember, this can be anything that you want it to be. It could be considered temp house, it could be house 1, it could be new house. It can be anything that you want it to be. And it doesn't even have to have the word house in it if you don't want to. It could be building 1 or something, but it just needs to be representative of what's going to be contained within it. Okay. Now, how would you use this constructor to create an object in a program? So we talked about this is the public definition statement that will be in our user-defined data type class. So how would you use this constructor to actually create an object in an actual demo or driver program? And so to do that, you could use this, for instance, house, which is the name of your class. New house is what I chose for my object name, but this can be anything that you want it to be, equals new brand new object instance, the name of my constructor, which is house, and then my parentheses are empty to match up here. All right, so let's take a look at this example. This is an explicit constructor because it has some values that are given to it that are explicitly provided, right? Public customer. The first value is data type string, and the user-defined data type class is going to refer to this by the variable name custName. The second is data type double, which means that there can be decimal places in the number, and it's going to refer to it by the variable name discount. So the class name for this above constructor, the constructor name and the class name are always the same, so it's customer. The constructor name, also customer. The explicit parameters, there's 2 explicit parameters. The first one, data type string, which is going to contain the name of the customer. The second type is data type double, which is going to contain some sort of discount. And then what would be a good object name? And again, this can be anything you want. It just needs to be representative of what's going to be stored in it. So it could be temp customer, it could be cust1, it could be any sort of thing that is relevant to you. And how would you use this constructor in a program, in a demo or driver program? Okay, so this is the definition statement that would be in your user-defined data class. To use this in a demo or driver program, it could look like this. Oops. Customer, cust1, that's the name I chose for my object, so this is the name of your class. The object name equals new customer, and I needed to provide it with 2 explicit parameters. The first, data type string, which is the name of the customer, and the second data type double, which is the discount amount. And so I provided Jones Topsoil and then 1.72. Okay, a method. Now, when you're doing your user-defined data type classes, you can define a method or methods within the user-defined data type class as well. So this is the whole beauty of object-oriented programming, is that your object is much more than just data. Your object includes not only data, but also includes actions that can be taken upon that data. Okay, so that's what a method is. It's an action that can be taken upon the data within an object. So a method always acts on an object. And we have two types of methods. We have an accessor method, which accesses, retrieves, or gets information from the object. And then so it doesn't make any changes, it's just retrieving information. And we have a mutator method, which is going to mutate, change, or set values in an object. So a mutator method is going to allow you to actually change the values of your instance variables. All right, to define a method, so again, this is going to be in your user-defined data type class. The method is defined. It can either be public or private, depending upon whether you want to restrict outside access to this particular method. For the most part, it's going to be public. Some different encryption routines, things like those, you might want to make private, but all of our methods will end up being public. A return type. If there is any, if any data is returned from this particular method, for example, an accessor method is obviously retrieving information, so we'll always return something. Mutator methods may or may not return something depending upon the purpose of the method. So something's returned, the return data type is going to go here. If nothing is returned, it's going to be a data type of void, indicating there is nothing returned. A method name here, and then whatever your explicit parameters are, if any, within the parentheses. Okay, so here's an example. This is an example of a mutator method. We have our access type is public. We have void, meaning nothing is returned. The name of our method is setName, and in the parentheses we have one explicit parameter of data type string that the user-defined data type class is going to refer to that data by the variable name in name. Okay, so the purpose of this method is to change the name to a brand new value. So the name currently has one value and we want to change it to a different value. Okay, so here's how that might look. So in the user-defined data type, this is where the method is defined. Okay, so it's part of that user-defined data type class. So public void set name, and then our explicit parameter. So nothing is returned. The name of our method is set name, one explicit parameter of data type string. Over here is the class or program that's creating the object and manipulating the object and using the object out in a real world setting, right? So the format for this, because it doesn't return anything, okay, is object name dot method name and then your explicit parameter. So if we created our object, whatever the name we created our object would go here, dot set name, and then we needed to provide one explicit parameter of data type string. So here we have Fred. Now this is always called from an object, so object name dot method name, and we have our string data type, our string data that we're passing back inside of our parentheses. Okay, this particular method is an accessor method. It's retrieving information, okay? And so it is going to return something. So again, data, it's public, so we have public access. The data type that's returned is going to be string, and we called this method getName. Our parentheses are empty, no explicit parameters, so we don't need any arguments passed to this particular method. So our accessor method, it retrieves the value of the name. And so here's how that would look. In our user-defined data type class, we're going to define that method. So public string get name with nothing inside of our parentheses. So returns data type string, name of the method is get name, no explicit parameters. In our class or our program where we're creating our object and manipulating that object, we're going to call the method. So we are returning data type string. So we need to store that information somewhere in some sort of a variable. So string, and I just called it outName here. So string outName equals. It's always called from an object. Okay, so whatever your object is that you've created, that's what's going to go here. Object name dot get name with empty parentheses, so no explicit parameters. So what's going to happen is this object call is going to happen. It's going to retrieve the value of the name, and then it's going to put the name into this temporary variable outName here. All right, so let's take a look at a couple examples. So here we have public double compute average with an open and closing parentheses. So what's the data type of the value that's going to be returned here? So it always follows the public. So we have double is our data type that's returned. What's the name of our method? The name of our method is compute average. And what are the explicit parameters? Our parentheses are empty, so there's no explicit parameters in this particular method. So how would I call this method? So remember, the public statement defines it inside of the user-defined data type class. So in my program, my demo or driver program, how would I go about calling this particular method? And this is just my example. It returns data type double, so I need to define a variable of data type double. So double average equals, it's called from an object, object name dot compute average, and there's no explicit parameters, so the parentheses are empty. Here's another example, public void set number with an explicit parameter of data type integer, which the user-defined data type class is going to refer to by the variable name num1. So again, what's the data type of the value that's returned? Here we have public void, so nothing is returned. What's the name of the method? It's set number. And what are the explicit parameters? In this case, there's just one explicit parameter of data type integer, which is going to be referred to in the user-defined data type class as the variable name num1. Okay. Public void, and how would I go about calling this particular method? And so it does not return a value, so I don't need to set it equal to anything. So I could do object name dot set number, and I pass in an integer value of 145, or I could say integer value equals 145, and then object name dot set value with value, or set number dot value here. Okay, so in this case, I'm providing it the literal value of 145. Here, I'm assigning a variable equal to the literal value of 145, and then passing that variable when I call the particular method. All right, test-driven development. So this can be really challenging, and I'm not going to lie, when I was first introduced to test-driven development, I didn't get it either. Okay, it's kind of one of those things that you really need to give it a try, really embrace, and you will come to appreciate it. Seriously, you will. All right, so the whole purpose of test-driven development is to write your test classes before you write your user-defined data type code. Okay, so the whole purpose of your test class is to run your user-defined data type through all of its paces, like trying everything out. Try out the constructor. Is that working the way we think? Try out all the methods. Are all the methods working the way they think? To try all that stuff out to make sure it's working the way that it's supposed to before you actually write a program and use it in a program. So you don't want to be debugging it as part of your program. You want to be running it through as the user-defined data type and make sure that that data type is strong before you let a program use it to create objects and manipulate those objects. However, with test-driven development, it's not before you write your program, it's before you even write your user-defined data type, which can be kind of confusing. Like, how can I test something before I've even written the code? So let me kind of go through this scenario for you to kind of give you the purpose, the whole point of test-driven development. Okay, so way back when I was very much a newbie programmer, eons ago, all right? I was actually working at Columbus State Community College at that particular time, and I was working on their registration system. And I had developed this new application for them, and of course, you know, it was amazing, of course, as only a newbie programmer can think all their code is amazing and awesome. And I went over to they were located in a different building from us, and so I walked over that building and I brought up my new application for them, and I'm like, here, you know, and of course I had written it and I had tested it and I had done all this stuff, and I just knew it was awesome and amazing. All right, and that is dripping with sarcasm there. All right. So then I went over and I showed them my app, and I'm like, give it a try. Let me know what you think. Let me know what adjustments you want me to make. And before I had even made it back to my building, which our buildings were located right next to each other, so it's not like this was a major jaunt or anything. You know, it was like maybe a 2-minute walk. They had managed to crash my program. And so how they crashed it is they had pushed like every function key just to see what each function key would do. And, you know, I don't know, they pushed like the F6 key, and the F6 key didn't do anything. But I had failed to anticipate them pressing the function keys. And so when they pressed F6, my program didn't know what to do, and it crashed right then and there. So yes, I had tested my code, but I tested it for how I had written it. So I anticipated them pushing the F1 key. I anticipated them pushing the F11 key, and you know, I did not anticipate that they would push the F6 key. And so rather than taking everything into consideration, I only took into consideration what I had written for, and I had not tested what I had not written for, and therefore they were able to crash my code. So the point of test-driven development is to try to think up all possible scenarios before you even write your code, and write tests for all those different scenarios. And then that way, when you do write your code, one, it is so much easier to write your code because you've kind of vetted out, well, what if they do this? What if they do this? What, you know, like you've vetted out all these different possible scenarios. So writing your code becomes so much easier. But then also as you write your tests, you can kind of determine, or you feel confident that you didn't write your test based upon how your code was written, but based upon all these different possibilities. Okay, so back to test-driven development. So the first thing you need to do before you write any code and you're working on your tests is develop what is the purpose of my method? Is the purpose to retrieve a value? Is the purpose to change a value? Like, what is the purpose of the method? Then take a look. What implicit parameter is required, which is your object, okay? And what explicit parameters are required? Like, what do I need to call this particular method? What do I have to have? What action is taking place in the method? Is it changing a value? Is it retrieving a value? And what sort of outputs? Like, are there modified? Am I returning a value? Am I changing the value of one of my instance variables? What's going on in this particular method? Okay. So let's take a look at this. So we have public void set name, and then we have an explicit parameter of data type string, which is going to be the name. So if we look at this, nothing is returned. We have a data type void. The name of our method is set name, and looking at that, it implies to us that it's changing the name to a new value. It's setting that name to a value. So this is going to be a mutator method, and I do have one explicit parameter, and we can assume this is going to be the new name, what I'm changing it to. So for the purpose, we can look at the Java docs for a description to see what is the purpose of this particular method. And in this case, it's to set the name to a new value. We can look at input. What explicit parameters do we have? We have one explicit parameter. The class is going to refer to it by the variable in name. It's data type string. What outputs? Nothing is returned, so we can't check for the return values, but we would anticipate the name of this, that this name is now going to be changed to the new value. So whatever value we give it, Fred, Joe, Amy, Sam, whatever, this is going to be the new name. So we can check, did it actually change my name to this new value? Okay, so here's what we know. The purpose is to change the name to a new value. The new value is stored in our explicit parameter, the in-name variable. And if the method is working correctly, when this method is all said and done, when it's finished executing, our name should now be changed to this new value. All right, so test, it is this same way every single time. When you're testing methods, you will always follow these steps. Step number 1, create an object. You have to create the object that you're going to be testing, okay? Step number 2, do any setup work. This step here may or may not be required depending upon what it is that you're testing. Step number 3, call the method that you're testing. And step number 4, make sure it did what it was supposed to do. These 4 steps happen every single time you're writing a test case for a method, okay? Create your object, do any setup work, call the method you're testing, make sure it did what it was supposed to do. All right, so assuming that this method is part of our dog class, all right, we have a constructor. This is a user-defined class, okay, and our constructor is public dog with 2 explicit parameters. First one string, second one integer. The first one contains the value of the name, and the second one contains the value for age. So step number 1 in test-driven development, create the object. So to create an object, it's very similar to what we saw in our program. We're creating an object, so we're not in the user-defined data class. This is a test class that we're now in. So dog, temp dog equals new dog, and then the first one is data type string. We're giving it a value of spike. Second one is data type integer. We're giving it a literal value of 2. All right, step number 2, do any setup work. So we're going to be changing the name of a dog. So we're going to need a string variable containing this new value. So here was our step 1, create our object. Here's step 2, do any setup work. So string new name equals Spot. So originally the name of our dog is Spike. We're going to be changing it to a value of Spot. Step number 3, call the method that you're testing. This is how the method is defined in our user-defined data type, okay? Public void, nothing is returned, set name, one data type or one explicit parameter of data type string. So call the method. So again, step 1 is create your object. Step 2 is do any setup work. Now we're going to call our method. We created our object with an object variable name of temp dog. Our methods are always called from an object. So temp dog dot set name, name of set name, and then we need to provide one explicit parameter of data type string. We have our new name is in our variable here, new name. I'm sorry, the new value that we want to assign the name is in our variable new name. So temp dog dot set name, new name. Okay, create your object, do any setup work, call the method that you're testing. And now make sure it did what it was supposed to do. And in test-driven development, we do that by using assert statements. These are special statements for test classes only, okay? And these are the ones we're going to be using. Assert equals, so assert equals with our expected value and our actual value. And assert not null or assert null. So in assert not null, we're checking, we're saying this actually contains value. Assert null, we're saying it does not contain a value, and then assert true and false. So we're saying we're asserting that this is actually a value of true and this is actually a value of false. Okay, so these are the 5 assert statements that we're going to be using in our test-driven development. So step 4, make sure it did what it was supposed to do, and here's how that would look. When we first created this dog object, this temp dog object, our name had a value of spike. We set up a variable containing a value of spot, and then we called the set name method with that value of spot. So we would expect, if this worked the way it's supposed to, that the name of our dog is no longer Spike, the name of our dog is now Spot, that it changed it to that new value. So we're going to do an assert equals Spot. This is what we're expecting, but we need to compare it against what it actually is. So we're going to call our getName method in our object to retrieve the value of that instance variable, to retrieve what is contained in our name instance variable, and we're going to compare what's retrieved against what we expect. So we're expecting Spot, we're going to compare it. If the 2 match, then our test case passes, and if the 2 don't match, then it doesn't pass, and we need to go and take a look and see what went wrong in our program. Okay, so let's take a look at another one. This is a mutator method here. It's called setBreed. So again, we would expect that this would set something to a new value. Nothing is returned. We have a void data type, so nothing is returned. We have one explicit parameter, which we would expect to be this to be the new breed that we're assigning. Okay, so again, the same steps. Create your object, do any setup work, call the method you're testing, make sure it did what it was supposed to do. Step 1, create your object. So temp dog equals new dog Spike, and 2. So Spike is our name, 2 is our age. We don't have a breed specified in this, so we would expect that to be set to a default value, perhaps unknown. Okay. Do any setup work. So our setup work, we set our breed. We created a new breed, a local variable, and we're setting it equal to a value of poodle. Call the method that you're testing. So tempdog.setBreed, and we give it our new breed, so we're passing it our value of poodle here. And then make sure it did what it was supposed to do. So we're going to do an assert equals. We're expecting the value poodle. We're going to call the getBreed method to retrieve the actual value of our instance variable here. We're going to compare these two against each other, and if they're equal, then our test case passes, and if they're not equal, then we've got a problem and we need to do some investigation. Okay, now API documentation. So JavaDoc provides us with a ton of classes out there. These are default classes that tell us how they can be used. So these are kind of like libraries that Java provides out there. So I'm just going to pull these up so we can take a quick look at them. Okay, so these are the JavaDocs here. You can also just do a search for JavaDocs in Google and you'll be able to get here as well. Over here are all the classes. Okay, you can actually, I think you can search for one. I'm going to go down and just pull up the string class. Okay, so here's the string class. So it tells us it's part of the java.lang.object. The string class is actually pulled in as a default for us. Let's see. We have constructor summaries, so these are different ways that string objects can be created. Okay, you can click on any one of these and it will pull you down and give you some additional information. And then we have different methods down here as well. So this is the data type that's returned. This is the name of the method and a description. So let's see. Index of, we have an index, here we go, index of string. So this returns the index within the string of the first occurrence of the specified substring. So it will take a look at a string, and let's say we specify like CH here, and we're looking inside of the string archbishop. So the CH would be located in positions 2 and 3. It goes 0, 1, 2, 3. So it would return to us position 2, which would be the first condition or first occurrence of CH within the string archbishop. You can actually click on index of, and it's going to give you a little bit more information here. Tells you what the parameters are and what it is that returns, and gives you a little bit of an example here as well. So these are the JavaDocs, all the different libraries and different classes, user-defined classes that have already been created for you to use. You can come out and search these JavaDocs and learn lots of information about them there. And that brings us to the end of the week 2 lesson. Certainly, if you have any questions, please do not hesitate to send me an email or post it out to Piazza. Either one will get my attention or the attention of your classmates.